Hi, good day, good morning, good evening, everyone. I'm happy to host our second joint OpenStack meetup with the online group and the OpenStack Israel group. We have a nice full house here in Israel. We are happy and excited to host Vasyl Avramov, CTO of Risk Focus, which is a specialist firm delivering custom solutions to capital markets. Vasyl has started his career as a developer in technology startups. Before that, he worked in risk management and sell-side capital markets. And we're really excited to have him here talking about DevOps for OpenStack, how to take a real-life bank and their complex IT using best-of-breed open-source tooling to the cloud. Not a simple task. So I'd like to welcome him, and our VP Product Management, Yaron Parasol, may be joining him partially during the call. Also, an OpenStack and cloud guy, so feel free to ask any questions you have. And without further ado, Vasyl, thank you.
Okay, thanks, Ron. All right, so guys, I'm, by the way, a really terrible public speaker, but I haven't had any time to prepare, so maybe it'll work out. So I'm going to take you through what the project that we're going to speak about is. So we're going to go through what the engagement is, because I work for a consulting company, so I'm going to go quickly through what we were engaged to do, what the project goals were, and then we're going to go quickly through the vision and the technology selection that we went through. Finally, we're going to look at some slides for the architecture. And because this was a project that actually started only about 3 or 4 months ago, we're currently at a very early MVP stage, so it's not going to be, I mean, there's going to be a lot of stuff that's still left on the table that we need to finish, but I'll also take you through what we decided to go live with. And then in the end, there'll hopefully be a bit of time for questions. So the client is a large North American bank. It's really a bank group, and what that means is that it consists of many vertical lines of business, and each of them kind of operates on its own. It has its own IT. The IT reports into the business line, and they're all essentially separate verticals, but they do share some common IT services. Namely, there is a shared infrastructure services. So, for example, of what the business lines are, for a bank, you will expect they might have credit cards, retail banks, and the retail banks in different countries operate as different businesses, again, with their own IT, with their own CIOs. And there's a group CIO who essentially tries to make sure that there's enough sharing and efficiency that can be gained from the group. So we were contracted by the infrastructure services, and the goal was to prove that we can take the bank to the cloud in literally 3 to 4 months with a team that started off as 4 people and peaked at around 10. So now the project is still ongoing, but we just completed the MVP. So these are really quite aggressive times for a large institution. Because of the structure with the various lines of businesses, flexibility is one of the really key requirements. We cannot create one solution that pushes all of these lines of businesses to behave the same way. I mean, again, they have different CIOs, they have different cultures, they have different requirements, they have different applications. And so it's very important to allow them to continue to govern themselves and not be shoehorned into a model which is not going to work for everybody for sure. You also want to allow for them to share some of the services that they built, but it needs to be optional. Now, one of the, I think, frequent misconceptions about cloud is that cloud is necessarily cheaper. Cloud is frequently a lot more expensive, especially for a large institution that has already made substantial investments in their own data centers. in their own hardware, in their own software, in the people that run these data centers. So really the reason for going to the cloud there was more agility. So that means that the ability to roll out new functionality to market quickly. And also, if that is successful, you want to be able to scale quickly. And I think these are like, if the goals of why you're doing a cloud solution are understood, I think that could lead to a very successful project. If they're misaligned, and if the goal is that you would immediately reach cost savings, that can lead to a disaster. Now, of course, the other great thing that the cloud offers is that it allows you to pay for what you use, right? Because typically, if you're not using a cloud solution, if you need to provision resources, you either need to over-provision just in case you need them, or you under-provision and then you're going to try and share environment. That's usually the most common situation, is that you share the environment, and there's a little bit of a just step on each other's toes that happens all the time in development, which leads to a tremendous waste of time. Cloud, of course, also allows you to reach various levels of efficiency. Firstly, because it's a virtualization solution, resources are kind of fungible. So you can have a machine that is shared by various units or by various different VMs. You can also self-service, and that's very, very important, because how do you usually get a VM in a large enterprises now? Either there's some portal that's been built where you can go in and submit a request, which then ends up going into somebody else's queue or email, and then there's some person who reads the email and pushes whatever buttons whenever they get around to doing it, and then email you back and tell you that your VM is ready. That's usually, not only is it very resource intensive, it usually also takes lots of time. And again, so that leads to usually bad behavior in terms of people over-provisioning or being pressured when they need the resource. And of course, there tends to be usually a fair amount of paperwork, because these are expensive resources, so they need to be monitored, and so you introduce more bureaucracy. So if you look at there was a bit of an animation, but the top part of this picture is the continuous delivery picture from Wikipedia, which talks about the benefits of making sure that your build can go from a single check-in, can go to a release cycle and go live purely automated. So that's, the benefits of continuous delivery are discussed in a number of books and papers, and it's clear that it's better to release frequently and release little, because then you might have little changes, and therefore you have less risk of failure. If you release less frequently, there's usually bigger releases, they take longer, and they're more risky, which leads you to release less frequently, which makes them more risky. So but again, this has been spoken and researched about a lot more coherently than I can. But one of the things that the picture sort of oversimplifies is that in a real enterprise environment, you can't just have the same environment take you through all of these steps. Like, you cannot have access to production data and probably a bunch of other production systems just within the same environment. So literally what you want is you want to keep the same spirit of automated jumping through the various gates, but you want to be able to move it through the different environments. So I think what's missing is the extra dimension that now we need to move an application across environments. So roughly on that picture, that essentially maps the dev maps all the way on the left, and the QA, UAT, and slightly kind of higher pre-production environments map in the middle, and then production is all the way at the release end. So in the traditional software development lifecycle, what do we have? We have people checking in code into some source control repository. Some continuous build server picks them up, executes unit tests, or maybe unit tests and integration tests, and in the end pushes some binaries out to a repo, which makes them it makes them candidates for a release. So this is great. It's a well understood and hopefully widely practiced process. The problem is that still the infrastructure side of things is manual. And so after this code, those binaries become eligible, they still need to be pushed out into the various environments frequently in a very manual way. So what I've seen so far, at least in the large banks, is that after all of these binaries end up somewhere, you write a really long Word document. I've seen ones that go well over 150 pages of instructions that say, take this thing and then run this command, which of course you can say maybe we should automate, but then there's, because the actual hardware is different, and usually people are not given permission to access this hardware, there's always a lot of manual work, which not only slows things down, but it also is very risky in terms of mistakes. And also the people who usually run these things are not the ones who wrote the applications in the first place, so they don't even know when they made a mistake, or they don't know how to diagnose it. So again, yeah, I've seen deployments which can take, after the code is written, can take 3 to 4 months. So instead, of course, one of the big premises of IaaS is that you can have infrastructure as code. So you can almost split the idea, and you can treat any application as consisting of 2 things. One is the infrastructure, and the other is the business logic. And the business logic is kind of encapsulated in what used to be the binaries before, and the infrastructure is encapsulated in some orchestration blueprints. And then you can actually just enable the classic blue-green or canary or whatever other flavors of various deployments there are. So going back to the slide of the various environments, there are some very qualitative differences between the environments. So in development, the emphasis is on flexibility. You want to allow people to experiment, and pretty much as long as they don't break anyone else, it's all good. So that, of course, you can confine within tenants, but in the higher environments, the emphasis is on repeatability. So really, there it's more about locking things down and just making sure that if you push a button, you will get the same result. So you don't want any level of changes. So, for example, even if I'm able to deploy a VM with Linux VM and choose the amount of memory in development and play around, that totally makes sense. But once I go into the higher environments, I need to make sure that whatever I've called my production VM comes up and executes the way I expected. I should not be allowed to change anything after I go to the higher environments. And of course, you can decide whether you want a sliding scale of restrictions. Now, and again, similarly to the slide, the continuous delivery slide, you can have triggers that allow you to gate the process, but in the end, there has to be some manual approval, which is the push button to allow it to move into production. So the idea was, the vision was essentially that we need to create a cloud service layer. So we wanted to work with an external hosting provider to essentially allow us to move quickly to market, because the bank didn't have a large, cloud run internally in the data center. we want, however, to be able to run in the internal data centers as well as on the external providers. So we want to make sure that the layer that the cloud services layer that we provide can provide a facade and seamlessly let us run from one to the other. Also, the goal is potentially going to be to have development and all the pre-production environments run off-premises, but all the production environment run on-premises where the bank can enforce more stringent security requirements. That also, of course, will allow us to not lose the existing investment in the data centers or the existing clouds. So we don't have to push everyone to move at the same time. And you can also, even in production, provide for burst capacity, because the external hosting providers will typically have more or less unlimited capacity as far as a single client is concerned. And finally, we do want to have that idea of write once, run anywhere. And so we want to be able to create kind of orchestration blueprints which allow us to span the different IaaSs. So probably the easiest way to think of what that cloud services layer is to think of it as an app store, where we've glued together a variety of generally open source components, not every single one of them, and they should provide the experience of an app store where in the shelves on the store initially you will get some very basic things, like you'll get a Red Hat VM or you'll have a JBoss. But then down the road, various LOBs, so the lines of businesses, will be able to put their exact applications onto the shelves of that store and then allow them to promote across the various environments. And of course, you want a single control plane that can manage the whole thing. And you want to make sure that the experience is seamless, and that's why we had to create essentially a facade, server, and UI that glues all of these components together. So then we went through a technology selection. And so you have to have some general ideas about what drives your technology selection. And for us, one of the very important ones was to start with be as close to standards as possible. Now, there aren't too many standards in this space yet. It's very, very hugely and rapidly evolving. So, but we decided to go with Tosca because, again, it's one of the very few standards out there. And also, over time, probably within a year, as the bank writes more blueprints, that becomes some very, very valuable IP. So we got to make sure that that's not completely coupled with a specific vendor. And I'm going to pass to Yaron for a second to describe, because I think it's clear that we chose Cloudify as the current orchestrator to use Tosca, and I just want to give you an opportunity to describe quickly, because I think you do it much more coherently than I am, what Tosca provides.
Thank you, Basil. So Tosca stands for Topology and Orchestration Specification for Cloud Application. It's an evolving standard by OpenOasis standard organization, and a lot of vendors take part in that, including Gigaspaces. And Tosca, the nice thing about Tosca is that it's application-centric. It describes the entire topology of the application in a declarative way, the different components, the relationship between components, the different lifecycle events that needs to be invoked per each component. And then it allows you to orchestrate any number of processes using an imperative workflow, and then you can use your favorite workflow language and your favorite workflow engine. Cloudify is probably the leading orchestrator for this standard right now, and it's completely open source. You can find it over GitHub. It combines the Tosca parser and the workflow engine and all the rest of those components that are needed in order to actually execute the Tosca blueprints over different infrastructure as a service environments.
So one of the other big drivers for us was to have a bias towards software that has a community around it. We want to be able to search for answers by Googling or post questions on news groups. It's, of course, a lot more efficient if you can self-service or if you work around a product that has a very large community. Now, there was a bias towards open source, and one of the main reasons also is that open source products usually have a community, and they're usually very amenable to creating communities around them. And of course, open source provides you with the ability to view the code, and so you can, in the worst case, you can self-service by looking at the code or fixing it. So again, it's not the move towards open source wasn't so much driven by the fact that it will be free, because most of the open source products have a license option. It was really because we want to be able to see the code and exploit the benefits of the community. The other big bias from an architectural standpoint was to go for components and not large solutions that provide all the benefits. It's a little counterintuitive, but in reality, even large solutions which are always composed of different blocks and therefore should be componentizable, it's very rare that you can pull a component out. Like if you buy a full service solution, you usually have to buy the full service solution and integrate it. And so that limits you, of course, on choosing necessarily the best of breed components, but worst of all, you have to take it all. And in a large, complicated enterprise ecosystem, you cannot take a humongous piece of infrastructure and just push it in and hope it works. It's much easier to go with things that are thin. That's a quick, it doesn't seem like this diagram came out too well after it was uploaded, but that's a quick picture of the architecture. So there's a bunch of products. There's a control plane which sits within the internal cloud, and within the control plane there's Cloudify, there's Git, Nexus, Packer, which is a tool to let you push images into the various IaaSs. We are using a configuration management tool, and so we chose OpenStack. We're using Cloud Cruiser to provide chargebacks, and we're using Splunk for both for monitoring our own solution, but also for providing any VM with an easy way to consume its logs. Now, each of these, this control plane manages multiple environments within each LOB, but the environments even within one LOB are completely segregated because they have separate networks and they have separate security groups. So the key features of that architecture is, again, separation of the LOBs, separation of environments. We're able to promote across the environments. There's a slide following immediately after that quickly graphs out how that works. We have one control plane that lets us see and manage all of these various environments times LOBs. Sharing of blueprints is possible, but totally elective. And we're using our own infrastructure to roll out our own cloud service layer. So because the cloud service layer or the app store, whichever way you want to think about it, consists of a bunch of different components, we use our own infrastructure to roll these things out. And it's very, very convenient. and also because we're changing the UI, for example, very rapidly right now, we're more or less at the moment deploying it out daily. So the way the promotion across the higher environment works is, at the moment, it's very simplistic. Again, we had very little time. So the idea is that we created the notion of a catalog, and essentially if you belong to a catalog, it means that you can exist in this environment, and then we allow only specific roles to promote from one catalog to another catalog. And to do that, because again, we had no time, we just leveraged the role-based access that is inherent in Git branching. So, because we had to go live and we have to come up with what is the least amount of work that we can do that still provides some value, we're going to roll this out to a very few tenants, and we're currently, our client base is only the development lifecycle. So it's purely development, and we also, again, if you'd like to think of it as a store, our store is at the moment reasonably empty, but it has the place where we can put stuff, and it has just enough things for it to be useful. So we have a Red Hat VM, the ability for developers to deploy a Red Hat VM. Of course, it's not a bare bones Red Hat VM. It comes with all the required security and monitoring tools, and it's integrated with Active Directory, so roles come directly from there. And there's a few app servers that we're supporting, so starting with DevOps and WebSphere. So then the question is, what's next? Well, Windows, and that's clearly a little bit harder, so we decided to push it off. We're going to start putting out the databases, load balancers, and whatever other requirements come down the pipe. We're essentially releasing in more or less 2-week sprints, so we can quickly take on new blueprints based on the demand. And then, of course, comes the hard and interesting task, which is taking the real NTR applications and moving those into the store as blueprints. So now we're talking about having your retail banking application becoming one of the items that you can choose to deploy, and not just a service like JBoss. We also need to work on scalability. At the moment, we've tested with hundreds of VMs, but this has to scale to thousands of VMs, meaning within one environment, within one tenant. We need ourselves much better continuous integration and continuous delivery, and there's going to be a lot of Docker. And Docker is going to be used for both the continuous integration and continuous delivery, because it's a very natural choice for that. And it's also going to be used for a lot of the kind of grid computing options that a typical bank requires, because it just lets you replicate the packages across a very, very large grid very efficiently. I think now it's time for questions.
So there's a question that came in. Thank you very much, Vasil, for your presentation through the online portion. You may have mentioned this, but what did you use to define the blueprints?
I'm sorry, I couldn't hear you.
What did you use to define the blueprints? And if you could also repeat the question so the audience in Israel.
So the question is, what did we use to define the blueprints? Do you mean in terms of language or in terms of requirements?
Let me get back to the person who asked that question, okay?
Okay. Okay. So in terms of language, we were using the Tosca YAML specification, which is a reasonably kind of early version, I would say, of a build file. I think it will. I'm sure it will be evolving quickly, but it's still a very good starting point. And as far as specifications, the specifications are driven by the applications that we're trying to put on. So typically, we put only the topology within the Tosca blueprint, and we put the rest of it in a salt script or salt formula, which then manages it so that we can make changes. Because of course the idea is that we want to bake as little as possible within each of the images, because that way you can change them. Because once it's baked into the image, it's quite static. So if you need to do upgrades, do patches, do security patches, it's very hard to do if they're baked into the image.
Just to quickly add to that, so the Tosca YAML file allow you to actually externalize the toolchain that you use, and it actually can be loaded dynamically as you go. So the blueprint describes the different tools that you use and gives configuration and configuration to those tools. Later you can also add monitoring specifications and policy specifications, but it allows you for a large flexibility. So if we started with SaltStack, we're now planning to add, for example, integration with Nexus and JBoss CLI and later some other tools. So that's the beauty of it. So you don't need new syntax and you don't need a new learning curve to integrate whatever tool you want into that blueprint.
Is there any other questions?
Yeah, so you mentioned your to Docker. So using Docker within the instances, or like what's the user architecture of Docker?
Can you just repeat the question?
Yeah, so I think that the question was essentially what are we planning to use Docker for?
What are you planning to use Docker for, and how are you planning to integrate it with the environment?
Yeah, sorry, so it's what are we planning to use Docker for and how do we integrate into the existing environment? So I think I like to think of Docker as just allowing us to create, in theory we could do all of it through Tosca blueprints, but it's just very laborious and quite a bit slower. So Docker just lets us package units almost like a war packages a bunch of jars. And so that way we can just have these much more instantiable units, and that's very useful on the one hand for anything around continuous integration or testing. You can use Docker to test source states. You can use Docker to test you can add Maven plugins. And so that's one usage, and the other one is going to be around, I think, a lot of the grid computing requirements. Because if you think about what classic grid computing solutions do, is they try and push a bunch of binaries so that they can execute them on various remote nodes, and it's just so much more efficient if you can just instantiate the images.